5 Three.js tricks. Rippling images using a fragment shader. In section 3 we looked at GLSL and how we can use it to do some amazing things. In this and the next video we're going to look at some more tricks using GLSL code. Shoot along to this address. In the starting template we've created a scene with an orthographic camera. An orthographic camera has values for left, right, top, bottom, near and far, and shows no perspective. We set this up so that the left and bottom are -1 and top and right are 1. We create the geometry of a plane using the sizes 2 wide and 1.5 high. The reason for these sizes will become clear in a minute. In the resize handler we ensure that this plane fills the rendered area in full. We first check the aspect ratio by dividing the width by the height. If this is greater than 2/1.5, then we set width to 1 and the height to the inverse of the aspect ratio, height divided by width. If it's less than 2/1.5, then we set the height to 1.5/2 and the width to the aspect ratio times the height. Then we update the left, right, top and bottom values. This simply ensures our plane mesh fills the screen and retains the aspect ratio 2/1.5. Let's replace the rendered pixels with a texture. First, update the uniforms. Add uText, value, new, 3.texture loader, set path, asset path, load, sa1.jpg. The variable asset path is set to my AWS folder where the image sa1.jpg is stored. Now, in the fragment shader, add Uniform Sampler 2D uText. An image texture in GLSL is a Sampler 2D type. The last step in displaying the image is to replace the color assignment with vec3 color equal texture 2D uText vuv.rgb. The GLSL function texture2D takes a sampler 2D instance and a vec2. Here we pass the varying vuv, which is passed from the vertex shader. Since it's a varying, it will be interpolated based on the current pixel that's being rendered. The function returns an RGBA value, and we're only interested in the RGB channels, so we strip them out using .rgb. You should now see an image on screen. Each value returned from the texture2D function are sometimes referred to as texels. We're going to play around with which texel to select from the texture image to give the appearance of a ripple. Don't worry, it's surprisingly easy. First, let's add a new uniform. Slide down to the uniform's definition and enter uDuration value 6.0. Great! We're ready to update the main function. Replace the existing code with vec2p equal vposition.xy, float len equal length p, vec2 ripple equal vuv plus p divided by len times 0.03 times cos len times 12.0 minus utime times 4.0. Float delta sin mod utime uduration divided by uduration times 6.23 plus 1.0 divided by 2.0. vec2uv equals mix ripple vuv delta. vec3 color equal texture 2D utext uv.rgb. The vec2p is set to the value vposition.xy. Then we save the length of this vector as the variable len. It's important that the center of the screen in this coordinate space is at 0, 0. We can do this using the varying vposition that ranges from -1 to 1 for our plane geometry. Now we want to create a new UV value, which we call ripple, that is the current VUV varying plus a value. Let's take a careful look at how we generate the value ripple. This is where the ripple will set the UV. By adjusting the value of UV, we can grab the colour of the current pixel from a different part of the texture image, a different texel. By default, we grab the texel from position VUV, but if we adjust this value, we can create all manner of effects. Imagine drawing a line from the centre of the screen to the test point. The pixel that we choose to use will be somewhere on this line, so we pull in the pixel colour from somewhere on the image that is either closer to the centre or further away. The direction is chosen by the value returned from the cos function. This takes the len value and multiplies it by 12. Try adjusting this value, we'll see that it affects the number of ripples, while the multiple of time simply affects the speed of the ripple. Try replacing delta with 0.0 on this line. Now you see a continuous ripple effect. The delta value coupled with mix interpolates between the ripple value for UV and VUV. When delta equals 0, the mix function returns ripple. When delta equals 1.0, the mix function returns VUV. Between these values, the return value is an interpolation of these two vec2 quantities. Take a look at how we generate the delta value. Simply take the sine of time, which will be a value between -1 and 1. We add 1 to this and divide by 2 to move to 0 to 1 as the possible values. The parameter that we pass to the sine function is the remainder of u time divided by u duration, i.e. a number that varies between 0 and u duration. This is divided by u duration to get a number that varies between 0 and 1, and then multiplied by 6.23, roughly 2 pi, so we get a number that varies between 0 and 2 pi. So we get a value that varies between 0 and 1 over a time span of duration. Using sine in this way is very common where time is included in a shader. Now we know how to ripple a texture,